When loading a mesh into shapes for the first time, you will get this loading guide, which explains the two methods for loading a mesh. Basically, you can either load the mesh with the current object selection, which tells shapes to find all symmetry components automatically, or you can load the mesh with the current edge selection to define the line of symmetry up front, so that shapes doesn't have to find it itself. It's important to note that the type of selection is only necessary for the first loading of the mesh. Once shapes knows the symmetry mapping, you can load the mesh with a simple object selection. You can also hide this window for further loadings once you are comfortable with the workflow, or bring it back through the preferences or by right-clicking the Load Mesh button. The loading guide also displays the various states of the symmetry icon, which by the way is not a button anymore, but only an indicator of the symmetry status. If you have a more complex model, like in my case, the selection method doesn't matter, because we have to manually define components anyway. The model I have here is the Great Croc character, modeled and set up by Andrew Silke from create3dcharacters.com. You can get this rig and a load of tutorials about it through a monthly subscription for the price of a large coffee, so it's definitely worth checking it out. For the purpose of this tutorial, I modified Croc a bit to give it some asymmetry, and all the various parts of the model have been combined into one mesh. The only exception is the belt, but again only for this tutorial. To start off, I run a simple symmetry check to show you which parts of the mesh are asymmetrical. This is just for display and usually not necessary. The symmetry check can be found in the menu bar underneath Tools, Check Symmetry. I use the default settings for the check. As you can see, the mesh is greatly asymmetrical. Now, I select the entire mesh and press the Load Mesh button. The loading guide shows up, and by pressing Load Mesh, the model gets evaluated. Depending on the resolution of the mesh and the number of shells, the process can take a few seconds. But this is only for the first time the mesh is loaded into shapes. Once the symmetry mapping is completed, loading the mesh happens instantly. Also, with symmetry mapping, mirroring target shapes is up to 60% faster than with previous versions. Once the mesh is loaded, the symmetry indicator displays one of three states. The light icon indicates that the mesh has been fully mapped. Red stands for partial mapping, dark gray for an unsuccessful mapping. In my case it's red, which is also what's expected with a mesh like I have here. In order to complete the symmetry mapping, we need to know which shells failed, so that we can help shapes to find the right components. I go to the Symmetry menu and choose Select Unmapped Components. This selects all vertices which the mapping process failed to assign. We can see that it's mainly the paired shells of the necklace as well as the eyes. The reason for this is that for each shell pair at least one vertex needs to be in an identical position. If this is not the case due to the asymmetry, the mapping is bound to fail. But we can fix this easily. And again, this is a one-time process. Let's start with the front bead of the necklace. This one failed because of overlapping shells. Since it's a spanning shell, it has an edge loop defining the line of symmetry. I select one of the center edges, and from the Symmetry menu I choose Add to Map. This adds the shell to the symmetry map. Next is the small thread to the lower, smaller bead. Same as before, I select one of the center edges and add this to the map. The smaller bead below is a bit different. Basically, it's a spanning shell, but missing the center edge loop. In this case, I need to select a symmetrical edge pair and use this to define the shell. The chain shell is the same. The center edge is missing as well. So again, I select an edge pair and add this to the map. To check our progress, I press Select Unmapped Components, and we can see that the shells we've just added are not highlighted anymore. For the sake of this tutorial, I fast forward so that there's only one shell pair left. After selecting the edges and adding to the map, we can see that the symmetry indicator has now changed from red to light gray, which means that we have completed our symmetry map. In order to check that everything is mapped as we expect, I randomly select one or more vertices and choose Display Component Siblings from the Symmetry menu. If the selection doesn't match, the mesh has either no topological symmetry, or the edge selection to define a shell or shell pair has not been correct. In this case, simply select the correct edge or edge pair and press Add to Map. You can also create a new mapping, delete the existing mapping, or transfer the mapping to another mesh. For the transfer, the loaded mesh is the source, and the selected mesh in the scene is the target. With the symmetry map in place, we can now easily symmetrize or simply start working with the asymmetrical model. The next time the model gets loaded into shapes, neither the loading guide window opens nor another evaluation is necessary, since the symmetry map is already in place. The advantage of the symmetry map is that all mirroring actions will perform much faster than before and are practically error-free. In case the symmetry mapping is not needed, you can disable it from the symmetry menu. When the mapping is not active, any mirroring actions are based on position. The tolerance value can be found in the Mirror tab of the Preferences. Lastly, a special case of mesh for the partial symmetry. My example is the free zombie rig from Sony Pictures Animation, which is asymmetrical for most parts without topological symmetry. This means that only parts of the mesh can be correctly mirrored, which can be matched by position. After loading the mesh into shapes and displaying the unmapped components, we can see that the jacket has almost no symmetrical vertices, which is no surprise according to the shape. The buttons of the jacket, on the other hand, could easily be mapped. The epaulettes are obviously not symmetrical. The pants appear to be mapped, but according to the shape this would be wrong, since they are not symmetrical. We can easily check by selecting one vertex and displaying the component sibling. As we can see, the two vertices are not matching, and this would lead to a wrong result when mirroring. Therefore, we need to fix the pants shell. I select one edge at the symmetry center and choose Add Partial Symmetry to Map. This tells shapes to perform an evaluation based on position. When displaying the mapping, we can see that the pants shell now has unmapped components due to the positional offsets. This is currently a technical limitation of the mapping process. All in all, the symmetry mapping might seem daunting at first, but it's easy to pick up and gives more flexibility and speed over the course of the blend shaping process. To finish off with an easy and probably most common example, we can try to load a mesh from the wonderful Kalo rig by Josh Sobel. Again, this mesh has been modified a bit to be multiple shells with some asymmetry, and this time we will only load the head. Since the mesh has topological symmetry across multiple shells, the symmetry mapping can be performed without any user input. With the mapping in place, we can instantly start creating blend shape targets and mirror these across.